Sorry about the interruption. So the radical 140, we know the factors are 10 and 14, and then 14 factors are 7 and 2, and 10 are 2 and 5, where we stop because they're prime. So I know that radical 140 is equal to radical 2 squared times 7 times 5. What can I pull out? That's right, the 2 squared, it becomes a 2, and 7 times 5 is left inside, so what's inside? 35. Excellent. So our answer is 2 radical 35. 2 radical 35 for A. And I'm going to give you 5 minutes to finish 10 with your groups and 13. Remember, to put a number back into the square root, you're going to be squaring the number on the outside and multiplying by the number on the inside. 5 minutes, finishing 10 and 13 with your groups. 5 minutes on the timer, please, and pause the video now. Let's see how we did on number 10. When I set up mine, I noticed that I was given my hypotenuse. So I had x squared plus 10 squared equals the quantity of 10 radical 2 squared. I notice that that's x squared plus 100 equals radical 200 squared. Because I put the 10 back inside, to do that I multiplied 10 by itself. 10 times 10 is 100. The number on the inside is 2, and 10 times 2 is 200. Now, when I square radical 200, I get just 200. I need to get x squared by itself, so I subtract 100 from both sides. When I do that, to get x by itself, I square root both sides to get x as a square root of 100, which means x is 10. What a nice answer. Moving on to number 13, notice I was also again given my hypotenuse and I'm solving for a leg length. When I end up solving, I have radical 41 being squared, which just gets me 41. Remember, squaring just undoes the radical. I end up with a squared plus 16 equals 41. Subtracting 16 from both sides, I get a squared equals 25. To get a by itself, I take the radical of both sides. The square root of 25 is 5. So my a value is 5. Nice. Let's move on. Since we have the Pythagorean theorem, we also have the converse. Not the type of shoe, but you can think about if the shoe's on the other foot. It's the other side of the story. For a triangle, if we have side lengths A, B, and C, and if a squared plus b squared equals c squared, hey, guess what? That triangle is a right triangle. So that's the converse of the Pythagorean theorem. So taking a look at this, the directions say circle the value that represents the hypotenuse. Determine if the side lengths given below satisfy the Pythagorean theorem and represent a right triangle. How am I going to know what value represents the hypotenuse? That's right, it's the biggest side length. We can't say it's the side length opposite the 90-degree angle because we don't know it's a right triangle. We also don't have a picture to look at. So taking a look at 14, what side length is the hypotenuse? 61, 11, or 60? You're right, it's 61. Moving on to 15, what's bigger, 9 or radical 15? Radical 15 is really close to radical. What's the perfect square closest to 15? 16. And radical 16 is 4. So what's bigger, 9 or something really close to radical 4? Sorry, radical 16, which is 4, 9 is bigger. So now let's look at radical 65 and 9. What perfect square is really close to radical 65? Radical 64, which is 8. So what is the hypotenuse? Radical 65, which is really close to 8, or 9? That's right, it's 9. 9 is the biggest side length there. Looking at 16, what's bigger, 2 or 4? 4. Now I need to think about 2 radical 5. Well, if I put the 2 back inside, I have to multiply it by itself. So 2 times 2 is 4, and 4 times 5 is 20. So this is radical 20. Radical 20 is bigger or smaller than 4? Well, 4 is radical 16, so we know that 2 radical 5 is the biggest side here. Now let's look at 17. What's bigger, radical 7 or 3.2? I know 3.2 is bigger than 1.8. Well, radical 7 is really close. Well, it's smaller than radical 9, which is 3. So radical 7 is smaller than 3, which means 3.2 is going to be the biggest side length. Now let's figure out if these represent right triangles. So let's see. If a squared plus b squared equals c squared, then this is a right triangle. All we have to do is substitute in the values. I know this is my c, so I'm just going to say a and b. 11 squared plus 60 squared should equal 61 squared if this is a right triangle. 11 squared, 121. 60 squared, well I know 6 squared is 36 and 10 squared is 100, so this is 3600. Equals 61 squared, grab a calculator. 61 times 61 or 61 squared or 61 caret button 2. Right, 3721. If I add 121 plus 3600, I get 3721. Hey, is this a true statement? Yes. That means I know this is a right triangle. Let's move on to another one. Number 15. A squared plus b squared equals c squared. If this is true, then this is indeed a right triangle. Okay, so let's go A, C, B. Since I know C, I circled earlier. Radical 65 being squared plus radical 15 being squared equals 9 squared. If this is true, it's a right triangle. Radical 65 squared, square root and squaring cancel each other out and I get 65. Radical 15 squared, radicals and squaring cancel each other out, so I get 15 equals 81. Well, 65 plus 15 is 80. Does 80 equal 81? No. That means 15, no, not a right triangle. I'd like you to look at number 17 with your group and figure out if it's a right triangle, yes or no. I'm going to give you 2 minutes to finish that. 2 minutes. Please pause the video now and give them 2 minutes to finish. Let's see how we did. Is it a right triangle, yes or no? If you said yes, then you are correct. Notice, be careful when you are squaring decimals with your calculator. We end up with 10 and 2400ths equaling 10 and 2400ths. So yes, this is a right triangle. Let's start looking at some word problems that are dealing with the Pythagorean theorem. Whenever we're dealing with word problems with the Pythagorean theorem, I really want you to think about drawing a picture. So let's take a look at 18 and see if we can draw a picture here. What is the length of the diagonal of a rectangle with a width of 1 inch and a length of 4 inches? I know what the diagonal is. Do you guys know what the diagonal is of a shape? A diagonal connects one vertex to another vertex that aren't connected by side lengths. So this is a rectangle, pretty good rectangle, and it has a width of 1 inch and a length of 4 inches. What are they asking us? Oh, to find this diagonal. Make it look more like a rectangle with this right angle. You guys, do you see what I see? You're right, it's a right triangle. So if I can find this hypotenuse, I know the length of the diagonal. So all of these we're going to be drawing right triangles for. So let's see, a squared plus b squared equals c squared. I'm solving for c. I'm going to make 1 my a and b my 4. 1 squared is 1. 4 squared is 16 equals c squared. 1 plus 16, 17. I want to undo squaring. That's right, square root. Both sides, C is equal to radical 17. Does 17 have any perfect square factors? No, 17's prime, but don't forget our units. So the length of the diagonal, always great to write a sentence if you can, is radical 17, what's the units? Inches. Awesome. See if you can do 19 with your group. I'm going to give you 3 minutes to finish 19. If you finish 19, feel free to move ahead. Pause the video now and give them 3 minutes. Did you get the side lengths of the square are 2 inches? Awesome if you did. If you didn't, somewhere you could have messed up. Is there x squared plus x squared? If you have one x squared and another x squared, that's just 2x squares. I have a lot of people try to tell me that's x to the 4th. That's funny. So please notice here you have to divide by 2. Divide by 2 first before you can take the square root of both sides. Awesome. Let's take a look at number 20. Find all the missing side lengths in this picture. We can do that because they're all what kind of triangles? Right triangles. Let's take a look. Okay, if this is 1 and this is 1, I need to find this one. Oh, you guys, let's use our trick where we know that if you add the areas, you can find this length. So this area would be 1 and this area would be 1. 1 plus 1 is 2. If the area of the triangle is 2, that makes the side length radical 2. Cool. Well, then we would have a new right triangle that has 1 and radical 2. Which means if I had an areas, 1 squared, this area is 1, radical 2 times radical 2 is radical 4, which is 2. So I know that this value is the sum of the 2 legs, which is 3. So if the area is 3, the side length is radical 3. Excellent. That's not too bad. So then the next right triangle we're going to be looking at has radical 3 and 1, and we need to find the hypotenuse there. Well, if we make those squares, 1 times 1 is 1, radical 3 times radical 3 is just 3. So if I add 3 plus 1 is 4, so that side length is a radical 4, 2. Radical 2, radical 3, radical 4, which equals 2. That was a little more fun than always having to rely on the equation. Let's always remember we can go back to this diagram where the leg square plus the leg square equals the hypotenuse square. One last problem. 21. A baseball diamond is the shape of a square. The distance between each of the consecutive bases, meaning 1, 2, 3, is 90 feet. What's the distance from home plate to second base? Round your answer to the nearest whole number. So let's see. If we're going from home plate to second base, hey, we have a right triangle. We know this is 90 and this is 90. So we want to find the hypotenuse length. Well, if I want to know the hypotenuse length, we can either use the equation a squared plus b squared equals c squared, where a and b are both 90, and you're solving for c squared. Or we could also use the picture method, and 90 times 90, or 90 being squared, well, 9 times 9 is 81, and 10 times 10 is 100, so 8100.